This video is going to show you an experiment that's designed to compare the brightness and the light emitted from this small torch bulb here with the electrical energy supplied to it. And we're going to measure the brightness by this light dependent resistor here. And I'm now going to show you the circuit diagrams for this. It's in two parts. One of them shows the bulb, and we're going to connect the bulb to a 12-volt stepped power supply, which means we can have voltages of 3 volts, 4.5, 6, 7.5, 9 and 12. And we are going to measure the voltage by the readings on the power supply and the current with this ammeter here. And you see at the moment we're not reading hardly any current because I haven't turned the power supply on. Here's the second half of the circuit where we have the light dependent resistor, and we're going to measure its resistance with an ohm meter, which you can see here, which at the moment is showing over range because its resistance is very large because it's dark inside the box. So let's turn it on and take some readings. So we'll have 3 volts to begin with, and you see the readings now. 138.2 is the resistance of the LDR and a current of 0.11 through the bulb. Next we'll go up to 4, and the resistance of the LDR drops now 35.2, yes, 35.2, and by the way, those are thousands of ohms, so it's K ohms each one. Now to 6 volts, and we have a reading of 0.15 for the current and a resistance reading of 13.2 for the LDR. Next we go up to 7.5 volts, and we have a current reading of 0.17 and the reading of the resistance of the LDR 7.6. Next 9 volts, and that means that the current goes up to 0.19 and a resistance now is 4.5k, and finally 12 volts, which will give us 2.3k and 0.22 for the current. The current readings are all amps. Now at this point I am going to go away and do some calculations based on those results and plot a graph for you, and we'll come back in a little while and have a look at the results of the experiment. Right. This sheet shows the readings taken and the calculations made from our experiment. Column 1 is the supply voltage applied to the bulb. Column 2 is the current through the bulb. Column 3 shows the variation in the resistance of the LDR due to the change in the light intensity from the bulb. Now column 4 is the calculation of electrical power supplied to the bulb, and that's obtained simply by multiplying the voltage by the current. The final column is particularly interesting because it shows the light intensity emitted by the bulb, and I've obtained that from the readings of the resistance of the LDR and this set of the characteristics of the LDR. Now this shows the illumination falling on the LDR surface, hence the light output of the bulb against the resistance variation. And from that we have the final graph of the change in light intensity resulting from the change in the power that we've applied to the bulb. And you see there's a slow change in light intensity initially, but finally a small change of power produces a large change in the light intensity of the output of the bulb.